Okay, Algebra 1, welcome back. We are in section 6.4, which is elimination using multiplication. So this is going to be very similar to 6.3 in terms of we're using elimination, but that was with addition and subtraction. This one we're going to use multiplication. So this one, they're not going to line up nicely for us just to add or subtract or even just multiply by the -1. We kind of did a lot of that with the -1. Now we're going to have to multiply by other numbers to make sure that we can eliminate. So again, we know that a system of equations is two or more equations, that we know. And when we eliminate with multiplication, it's going to be basically the same as elimination with addition or subtraction, with a couple little differences. And those differences are you will not always have the same coefficient. So in this case, you'll have to multiply every term in an equation to make common coefficients. And really, one equation should work. There are cases where we're going to have to multiply both, and we'll do an example of those as well. And then when we get those common coefficients, we want to have opposite signs as well, because remember, we know that to eliminate, we have to have one positive and one negative to get rid of them. So that's one difference. And then the big thing, your answer, as always, is an ordered pair, an XY ordered pair. Okay, so let's roll into the steps for elimination using multiplication. So just like in elimination with addition and subtraction, we're going to make sure our variables, our equal sign, or a constant are all lined up. And then we can try to look and see at coefficients and decide what can easily match up. We have to kind of study these and say, which is going to be easier for me to deal with, the x coefficients or the y coefficients. And then here, we're going to have to actually multiply the entire equations. Be careful with your signs, your positives and negatives, and make sure that we are careful with that. But we got to make sure the entire equation, that means the constant on the other side of the equal sign as well. And then we want to add the equations, and we're going to eliminate one variable. After we multiply, then we can eliminate using addition and subtraction. And then you remember we'll always have an easy little equation to solve. We solve that. And then we're going to, after that, substitute to find the value of the other variable. So those are our step-by-steps. So let's get to a practice problem right off the bat. All right, so I'll use elimination with multiplication to solve this system of equations. So when we look at this one, we're just going to look at our coefficients. I don't care about the variables. We're all lined up. We're good to go. So I don't care about the variables. I'm looking at the coefficients. Here I've got a 3 and a 5. And then my y coefficients, I have a 4 and a 2. So we're looking at what would be the easiest way to eliminate here. Well, the 3 and the 5 together, what do they both go into? They both go into a 15. That's the smallest number that they both go into. Where over here with the y's, 2 and 4, they both go into 4. So I'm going to try to eliminate the y's, because that way I only have to multiply by one equation. So how could I get a 4? Well, in my y values here, I already have a 4 in the first equation. In the second equation, I have a 2. So I have to multiply that second equation by 2 to get 4. So I'm going to multiply everything here by 2. And I also, because they're both positive, I want to get a -4y, so I'm going to have to multiply it by a -2. So if I multiply everything by a -2, then I should be able to get eliminate those y's. So let's rewrite the equations here. The first one, nothing changes, so it's going to be 3x plus 4y equals 6. And now the second equation, I'm going to actually multiply. -2 times 5x gives me a -10x. -2 times 2y gives me a -4y. You can see kind of now we have what we want. And then -2 times -4 will give us a +8. So now I have everything set up for me to eliminate by using addition. So if I add these two up, 3x and -10x is going to make a -7x. You can see my y's are going to eliminate, so they're gone. I can bring my equal sign down, and then I can add 6 plus 8 is 14. And now you can see that if I divide through by a negative 7, then I'm going to have x equal to a negative 2. So I've got my x value. Now I have to substitute that negative 2 in to any equation I want. It doesn't matter. It doesn't matter if I use the first one or the second one. I'm going to use the first one just because I think 3, 4, and 6 are easier to deal with than 5, 2, and is negative 4. So I'm going to sub this next negative 2 into the first equation. So I'm going to go ahead and write the first equation up here again. 3x plus 4y equals 6. That's 6. I'm going to rewrite it. Okay, equals 6. And then remember, I'm taking this negative 2, and I'm going to substitute it in for x because we already solved for x. So now I've got 3 times negative 2, which we know is a negative 6, plus 4y equals positive 6. Then when I add 6 to both sides, these are gone, so now I have 4y equals a positive 12. And then dividing through by 4, I end up with y equals 3. And so then my final answer here would be negative 2, comma 3 as an ordered pair. Okay? Let's go to this one. In this case, again, looking at the coefficients, I'm just going to take a look. I've got a 2 and a negative 1 for my x's. And for my y's, I've got a 3 and a 2. So when I'm thinking about what I could do, well, 3 and 2, what are they both going to? Well, they both go into 6. But neither of these is a 6, so I'd have to multiply both. So I don't like that. Let's look at this one. I've got a 2 and a negative 1. What do they both have in common? What do they both go into? Well, they both go into a 2. And since this one's already a 2, I'm in good shape. So I'm going to try it for the x's. So basically, how can I get this bottom equation to turn it into a 2x or a negative 2x? Well, I would multiply everything here by 2. And even a bonus, I don't have to multiply it by a negative 2 because 2 times negative x is going to be negative 2x. And those x's will be ready to be eliminated. So rewriting the equations, 2x plus 3y equals 4. That's the top equation. The bottom equation is the one I'm multiplying and trying to eliminate with multiplication. 2 times negative x is negative 2x. 2 times 2y is a positive 4y. And then 2 times 5 is a 10. And this is the part where people always forget to multiply this 5 over here by 2. To get 10, you have to multiply everything in the equation. All right, so now when we are going to add here, now we can eliminate with addition. So we see that these are going to cancel out. So now I can bring down my 3y and 4y, make a 7y, equal sign, and 14. And then I just have to divide through by 7, and y would equal 2. We got my y value. And now, again, I can substitute y in for either of these. Now, I don't like the negatives, so I'm going to use the first example, the first equation, to substitute it in. So I'm going to go 2x plus 3y equals 4. And remember, I'm going to take this y equals 2. I'm going to substitute that in for my y here. So 2 is going in. So now it's going to be 2 times x plus 3 times 2. I use parentheses when I substitute in. Equals 4. Now I have 2x. 3 times 2 is 6. Equals 4. And now it's just a two-step algebra problem. I subtract 6 from each side. And now I'm left with 2x equals a negative 2. And then if I divide by 2, I end up with x is negative 1. So I've got an x and a y. The only thing I have left to do is put it into a ordered pair. X is -1, y is 2. Make sure my x is first, my y is second, and there is my final answer, -1, 2. Okay? All right, let's do one more. And the reason we're going to do one more is we've done one where we eliminated x. We've done one where we eliminated y, and we've multiplied by a positive and a negative. But let's do one where we have to multiply by both equations, because that sometimes happens. So again, if I look at this one, I have, and you know what, let's go ahead and eliminate the y's here, just to make that decision. So I look at these, it could go either way, really. But I got a 4 and a 3. What do they both go into? They both go into a 12, all right? And the reason I chose the y's is because you have a positive and a negative here. So I know if I just multiply by a positive, I should be in elimination mode. So in this case, I have to multiply both equations. So what do I have to multiply the top equation here to get a 12? Because I know I want to get these in common. I'd have to multiply that by a 4, or excuse me, a 3. A 3. So if I take this top equation and multiply it by 3. And then the bottom equation, I'm going to multiply by 4. Because then if I look at my y's, I'm going to have a 12y and a -12y, and then I'll be able to eliminate. So let's go ahead and do that multiplication. So the top one first. 3 times 3x is 9x. 3 times 4y is a positive 12y. And then a 3 times -25, don't forget that one, is going to be -75. The second equation, 4 times 2x is 8x. 4 times -3y is -12y. Now you see why we did that, because we can eliminate those y's. And then 6 times 4 is 24. So now I'm in the position where I can eliminate using addition. The 9 and the 8x make a 17x. These will cancel. So now I can bring down my equal sign. Now I have -75 plus 24, which happens to be a -51. And now I'm in a position where I can divide by 17, and now I have x equals -3. And once again, I'm going to pick an equation. It doesn't matter which one I pick. I could actually pick these two over here to the right after multiplying if you wanted to do that. But let's plug it into one of these. I don't like the -25 here, so I'm going to use the second one. Plus, we haven't done that yet. So 2x minus 3y equals 6. And remember, I am substituting in this -3 in for x. So now I have a negative, let's just write that out for us before we do anything crazy. So it'll be 2 times -3 minus 3y equals 6. And now I have -6 minus 3y equals 6. And then I'm going to add 6 to both sides. So these are gone. -3y equals 12. And then when I divide through by a -3 on both sides, I end up with y equals -4. So that my ordered pair now would be -3, -4. And again, what that means is if I graph those two equations or those lines, the original two, they would cross at the point -3, -4. That's our solution. Okay? Extra practice problem there for you. Let's get to the lesson summary. What is one important thing to remember when solving a system by elimination? Again, it's going to be different for each person. What do you think you need to remember when you're solving a system by elimination? And then this one here, solve this system. 4x plus 3y equals 8, and 3x minus 5y equals -23. A little hint, you should get whole numbers. There'll be no decimals or fractions here. And another hint would be you're going to have to multiply both equations here. So it'll be just like, kind of like the last example we did together. Okay, so that's it for 6-4. And we will bring your questions and we'll go over them tomorrow.